And Pierce, this is Dr. Jones checking in. This is a video lecture for A&P 2, lecture test 3, video 3. We are starting at the bottom of page 5 with blood types. So where I am, I know the page numbers sometimes print out differently, so I'm at the beginning of section 19.3. ABO, RH are based on antigen-antibody response. So this is where we are. So this is our picture in the book, or perhaps an older version of the book. There's my pen. There's the pen. Okay. So what we need to know about blood types. The antigens are things that can trigger an immune response. Any antigen is something that can trigger an immune response. So an immune response is the body's defense mechanism. And the surface antigens are antigens that are on the surface of the cell. And they tell the immune system whether this cell is self, part of you, or it's foreign, needs to be attacked. And then bottom should say transfusions, that bottom line on page 5, make it say transfusions. If it doesn't, transfusions, and it's important to donate blood, but with transfusions you have to make sure that you match the blood types. So let's talk about this picture before we move on and how the blood types work. So let's go with red here. So the surface antigens in blood type A are little a surface antigens. Okay. And if you have blood type B, can we get pen cut? Yeah. Okay. So if you have blood type B, then your red blood cells make the B surface antigen. Now, if you are blood type AB, then your body makes both the B surface antigens and the A surface antigens. So if you have a gene, a single gene or two genes for the A surface antigen, then you make the A surface antigens. If you have a single allele or two alleles for the B surface antigen, then you have type B blood. If you have one allele for type A, you make the A surface antigen, and an allele for type B, you also make the B surface antigen. Later, we will call this being co-dominant. Now the one that's missing underneath there is type O blood. Type O has 0 surface antigens. In fact, this type was originally type 0 and it got misread as type the letter O. So that's why it's type O, because it has 0 and they're hard to tell apart. So no surface antigens for type O, and that's what's under my head there. So if you are born with type A blood, you know what, let's do this one. We're going to do type B first. If you are born with type B blood, you are born with anti-A antibodies, and antibodies are part of your immune response. They're immunoglobulins. Okay, so these they stick to type A blood, the type A surface antigens, and rip them apart. We see that down here. Let's do the B blue. Okay, so if you're born with type A blood, you're born with anti-B antibodies floating around in your bloodstream. And this is a representation, is a symbolic representation of both the surface antigens and the antibodies. They don't look like this, but what they have represented here is that the shape is what makes them work. Surface antigens they've represented as surface antigen A, they've represented as round, and the anti-A antibodies as round. The surface antigen B they've represented as triangular, and attacking it is the anti-B antibodies. So the anti-B antibodies only attack the B surface antigen. And what that looks like, more or less, is an agglutination, which is a clumping. because the anti-B antibodies attach to the B surface antigens, and then that causes hemolysis. Hemolysis, hemo means blood, lysis means a loosening of, so it explodes your red blood cells. And this is what we would call a transfusion reaction. This is what's happening. You get the agglutination, which is the clumping, which leads to hemolysis, which is not consistent with life. Is that gently put enough? If you have a transfusion reaction, a patient with a transfusion reaction, you have a few minutes. So if you have type AB blood, you of course don't have either of the antibodies, neither the anti-A antibodies or anti-B antibodies. If you had anti-A antibodies, you would break up all of your red blood cells. If you had anti-B antibodies, you would break up all of your red blood cells. And type O blood, you can almost see here, has both anti-A and anti-B antibodies. So these are the main blood types. They are A, B, AB, and O. And these are from the ABO system. So the ABO system is part of how we show these. Okay, but that's not the whole story. So let's whiteboard up W. Okay. So how we test for blood types. You get a sample. Can y'all see that it's flickering? Okay. You get a sample and you get 3 wells. In the first well, you put anti-A antibodies. So a serum with anti-A antibodies. I meant to do that in red. And then the second one, you put anti-B antibodies. So then, when you add blood to this, in the anti-A antibodies, if you see spots or clumping or stippling or agglutination, then you know you have the A surface antigen, because the anti-A antibodies only attack the A surface antigens. So if you see the clumping or agglutination, the anti-A found something to attack, and the only thing it attacks is right there in the name, anti, I for against, anti-A. So say this one has clumping, agglutination in the anti-A serum. We know it's got an A surface antigen, so it's type A, but no reaction, just smooth blood in the anti-B serum. Then we know there's no B surface antigen because there was no reaction, no agglutination, no clumping. Okay, I'm going to draw a bunch more, and we are going to go through how to test for all the blood types. Just a second. I think that got it. We can draw more. Can't erase them now. Okay, so let's skip a set. Let's say for the next sample, we had no reaction in the anti-A antibodies, but stippling, clumping, agglutination in the anti-B. Anti with an I means against, whereas anti with an E means before, like antebrachium or antebellum or antemortem, or antemeridium, which is AM in the morning before the noon. Okay, anti with an I means against, means fighting. So anti-B antigen antibody only fights the B surface antigen. So this sample goes across, has no A surface antigen because we see no reaction here. In the anti-B antibody, we do see a reaction, so we do have a B surface antigen in this blood sample. Skip one, and then we are short one. What if we have stippling in both the A and the B, anti-A and anti-B? Then if we anti-A found something to react against, then there is A, because the anti-A only attacks A, and it attacked. That's what caused the clumps, the attack. And so we know we have a surface antigen. There's also clumps in the anti-B, and it only attacks B, so we know we have B surface antigen. Seeing the pattern here. So what if we have no reaction? Oh, we got nothing. And I was right, we were short. So blue, one more. So this is the ABO system. But this isn't how we report our blood types. We don't only use the ABO system. We also say if they're positive or negative, A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, O negative. That's all of them. And this is the RH system. And the RH system is so named because it was first found in rhesus monkeys, which is an RH rhesus. And if they had this in their bloodstream, then they were RH positive, and if not, then RH negative. And after they found it in rhesus monkeys, they said, oh, well, let's see if this is in humans. Guess what? We have it too. So to test for the RH factor, we use anti-D. I don't know why D doesn't make any sense to me either. But this is the column that tests for the RH factor, and it's either positive or negative. So back to red. Boom. Okay, so if we have stippling in the anti-D or RH column, then we know we have the RH, so we are RH positive. So this samples go across, is A positive. What if we have pattern of stippling, no reaction, no reaction. Anti-A only attacks A, dots means it attacked, so definitely an A. Smooth means no attack, so no B. Smooth means no attack, so no RH. So this one is negative for the RH factor. Next, let's add a reaction in the anti-D column. So we have no A, yes B, yes RH. So yes RH is written as a superscript plus. Same thing except, oops, no reaction in the anti-D column. So no A, yes B, no RH, which is written as B negative, which is terrible life advice. And what if we have all stipples all the way across? Then we are at AB positive. What if we have reaction, reaction, no reaction? That is AB negative. What if we have no reaction, and stipples, or clumps, or agglutination? We're at O positive. And what if we just get smooth sailing the whole way, no reaction? Then that is the O negative. So the two things that we use for blood types are the ABO and the RH factor. Together make our blood types: A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, O negative. So what, sample test questions, what blood types would react to anti-A serum? Well, we can just go through the pile here. A positive, A negative, AB positive, AB negative. Which blood types react to the anti-B antibodies? Well, let's just go through here. We've got B positive, B negative, AB positive, and AB negative. Which blood types react to the anti-D antibodies? A positive, B positive, AB positive, O positive. So that's how blood types work. Okay, we talked about Punnett squares. Can I make a video about Punnett squares? Okay, so for type A blood, you can have one type A allele or two type A alleles to make type A, it's supposed to be an A, type A blood. For type B blood, you can have one type B allele or two type Bs. Either way, you will have the B surface antigen and be a type B, blood type B. If you have a gene for type A and a gene for type B, they're what they call co-dominant. I won't test you over that until test 6. But they both show up. So if you have the gene to make the A surface antigen, you make A surface antigen. If you have the gene to make B surface antigen, you make B surface antigen. And if you have both genes, you make both surface antigens, and that's how you get type AB blood. If you don't have either the type A gene or the type B gene, then you have type O blood. So, given this, is it possible for two type A parents to have a type O kid? Well, for this type A mama, because mamas go across the top of the Punnett squares, half of her eggs will have an A. And we're not sure about the other half because we don't know if she's a O or a A. There's terms for those, and we'll get to those for test 6. And for this papa, because papa's genes go down the side, half of his sperm will have a type A, and half of his sperm we don't know yet. Excuse me. So the question was, is it possible? Now we know these 3 kids are all going to be type A. So is it possible to get a type O kid? Yes. If both parents have a type A and a type O. Now, is it possible for two type O parents to have a type A kid? Well, the only way to be type O is to have 2 type O genes. So half of mama's eggs are going to have this O, and half of mama's eggs are going to have that O, and half of papa's sperm are going to have this O, and half of papa's sperm are going to have that O. So no, it is not possible for 2 type O individuals to have type A kids. It is not possible for 2 type O individuals to have anything but type O kids. So if 2 type O individuals have a type A kid or a type B kid or type AB kid, something happened, but this is not what happened. So is it possible for 2 type B parents to have a type O kid? Type B, question mark, type B, question mark. And we know that these 2 kids will have a type B because of mama, and these 2 kids will have a type B because of papa. So is this possible to have a type O kid? And the answer is yes, if both parents have that hidden, sneaky, recessive type O that they are quote-unquote carrying. So it is possible for 2 type B parents to have a type O kid if they are both BO, which is heterozygous because they have hetero different, as opposed to homozygous, which means same. But it is not possible for 2 type O individuals to have a type B kid. Okay, so how do you get, what happens if you have a type A that's heterozygous with a type B that is also heterozygous? This one's my favorite, because here you have this half of mama's eggs have an A, and this half of papa's sperm have a B, and then everything else here is an O. So this one is my favorite to plot out because you can have a type A parent and a type B parent if they both also have an O. It's possible to have 4 different kids with 4 different blood types. Because look, this kid has a type AB blood, type B blood, type A blood, and type O blood. Isn't that fun? Yay. Okay, so this is how you test for the blood types and some Punnett squares for how the blood types work together in the genes. So expect test questions on the Punnett squares and the blood types. These blood typings are also expected in the lab tests. Did I put a timer on this time? Nope. How are we doing? Okay, well, let's finish this section, if not the page. Okay, so the blood types we've already talked about: A positive and negative, B positive and negative, AB positive and negative, O positive and negative. And the ABO blood group gives you the A, B, AB, or O. The RH group gives you the plus or minus. Agglutinogens, ooh, we didn't talk about that. Agglutinogens are the surface antigens. Antibodies are the agglutinins. Agglutination is the clumping that we talked about, and sensitized is when you come in contact with a different type of blood and become sensitive to it, which means you make the antibodies against it. So if you're born with, going back, type A blood, you're born with the anti-B antibodies, which is weird. If you're born with the type B blood, you're born with the anti-A antibodies, still weird. But if you're born with the RH negative, you are not born with the anti-RH antibodies. But if you come in contact with Rh positive blood, you become sensitized and form anti-Rh antibodies, which we'll talk about here in a second. There are actually lots of surface antigen, like 50 different surface antigens that we can become sensitized to. People who get lots of blood transfusions often become sensitized to lots of other surface antigens, to the point where you have to test for lots of other markers before you give them transfusions, because they can have transfusion reactions to many different surface antigens, not just the A or B or Rh if they're sensitized. So notes on transfusions. You want to, if it's not compatible, the transfusion reaction is also called a cross reaction. And let's talk about hemolytic disease of the newborn, which is abbreviated HDN, hemolytic disease of the newborn. So what happens is, if you have an Rh negative mama and an Rh positive baby, squash. Excuse me, some in my throat. So with an Rh negative mama and an Rh positive baby, again, there is a placental membrane, and the red blood cells do not cross the placenta. So mama's red blood cells do not enter baby's bloodstream, and the fetus's red blood cells do not enter mama's bloodstream unless there is bleeding, unless this membrane is damaged. So any kind of placental bleeding will allow mama's and baby's bloodstreams to mix, allowing the red blood cells to cross. If this does not happen during pregnancy, it will happen at or just after delivery, where the placental tissue abrupts and is removed from the surface of the interior. And that allows these Rh positive blood cells into mama's bloodstream, and mama is then sensitized and forms anti-Rh antibodies, which after this first Rh positive baby has been born is just fine until mama gets pregnant again with a second Rh positive baby. Now, mama's red blood cells may not cross the placenta, but the anti-Rh antibodies do cross the placenta, enter the baby's bloodstream, and hemolyze all of their red blood cells. So this is hemolytic disease of the newborn, and it is not consistent with life for the second or any other pregnancy involving an Rh positive baby. Now we do have treatment for this now. We have shots called RhoGAM, and the RhoGAM is an artificial anti-Rh antibody that is injected into mama anytime there's placental abruption or bleeding, and also again at delivery. There's like certain numbers of weeks. Usually somebody in the room knows, because I never can quite remember that one, which week those are injected. Somebody knows. Google knows. The treatment and management of HDN would be an interesting topic for an extra credit essay. More detail than what we've covered here, of course. And so the RhoGAM is injected into mama's bloodstream to destroy the Rh positive red blood cells before mama can become sensitized. So that prevents mama from making the anti-Rh antibodies, which would prevent them from killing any future pregnancies that are also Rh positive. Okay. And next picture. Yeah, that's the next thing. We will do the white blood cells as a group in the next video. So this has been ANP 2, lecture test 3, video 3, note sets pages 5 and 6, which I'm going to write down. Next, we will start video 4, which will start with note set page 6. So, thank you as always for tuning in. The education must go on. Dr. J out. Okay, wait. It's worked last time. In order, command and then control and then escape. Thanks, y'all.